Hi, my name is Chongkwang Park, and I'll be presenting real-time object detection YOLO version 2 using Pytorch. The automatic license plate recognition system is to detect and capture license plate on vehicles, and many of them are used based on vehicle detection using machine learning, which can remove tedious work and time for collecting data. You look only once YOLO is one of the most popular machine learning algorithms for object detections, and some ALPR systems are used YOLO models to detect vehicles. So I decided to re-implement YOLO version 2 model to fully and deeply understand object detection architectures using Pytorch. Here is the basic theory of how YOLO version 2 detects an object. As you can see on the left, basically an input image is divided into S by S grid cells, and each grid cell is responsible for predicting bounding boxes, confidence scores of each box, and class probability of each box. YOLO version 2 has 13 by 13 grid cells, 5 bounding boxes, and 20 classes of object. Bounding box contains 4 parameters of box coordinate and 1 confidence score. So X, Y, W, H are the box coordinate parameters, which is proportional to the boundary of the grid cells. And the confidence score is determined whether an object is at the bounding box. So the confidence score is 1 when the object exists at the bounding box. So each bounding box has 5 parameters. The class probability is to whether an detected object is assigned into given classes. And YOLO version 2 have 20 classes of objects. And because of using a fine-grained features, the output feature map is 13 by 13 by 125. So here's the main convolution neural network architectures of YOLO 2 version 2. The YOLO uses existing network called VGG16. It has 2 fully connected layers. However, the paper proposed a new classification network called Darknet19. Although the Darknet19 is similar to VGG16, it has batch normalization and removes 2 fully connected layers. So since removing fully connected layers reduces the number of parameters of the models, so this makes the model faster than YOLO. The image on the right side is very similar network to Darknet19 except some layers. The pass-through layers are added for detecting small objects called fine-grained features. So the Darknet19 is trained using ImageNet dataset and the fine-grained features using a Pascal VUC dataset. YOLO version 2 doesn't have a detailed information regarding on loss functions, so I used a loss function from a YOLO. The loss function uses the sum of square error method, and it consists of 3 losses: localization, confidence, and classification loss. Localization loss is measure the error with respect to the predicted location and size of the bounding box. And the top confidence loss equation is when the object is detected, and the bottom is when the object is not detected. And the classification loss is a square error of the class conditional probability. So when the object is not detected, it is 0. The code image shown at the left is the loss function. I summed all 3 losses and trained my model. Although I trained my model using GPU in my laptop, it took around 20 minutes per epoch. The YOLO version 2 trained the model for 160 epochs. If my laptop run 160 epochs, it would take around 54 hours for training, which is more than 2 days. But unfortunately, I could not train my model for 54 hours, so I only trained my model for 8 epochs. My MAP, mean average precision, is around 31, which is quite lower because the YOLO version 2 has 73.4 MAP. The graph on the right top is a total loss during 8 epochs. I collected loss data every 20 batches, and fortunately the total losses decreased. Another graph shown below is the 3 different losses. The confidence loss is decreased abruptly, and all the losses is converging to 0. One of the reasons that my MAP is lower that I did not train using ImageNet dataset. So I hope to pre-train my model using ImageNet dataset and train using Pascal VUC dataset for 160 epochs. And since there are a few updated versions of YOLO, I hope to re-implement YOLO version 5 and use it for automatic license plate recognition system. That's it for my presentation, and thank you for listening.